All right, so to interpret proportionality of graphs, we have to look at several things. One, if you remember from last week, we talked about what is a proportional graph. And so there's two things that have to be the case. One is this a straight line? And ignore my drawing, but as you can see, it is a straight line. The second thing that has to be true is that the line has to pass through what we call the origin. And so does it pass through where we have 0 and 0 on the x and y axis? In this case, it does. So this graph is proportional. Now, what we want to do then is we want to be able to interpret what that particular point right there means. And so we have to look at the numbers, the 1 and the 0.5. We have to look at the units that the graph gives us as well. And so there's two ways you could tell what this graph means. One is you could start with the x values and say that 1 minute is how long it takes 0.5 gallons to be used or to fill up. We don't have a lot of information about what the gallons are. Are we draining the gallons or are we using it to fill it up, something? So that's one way of looking at it. The other way to look at it then would be .5 gallons in 1 minute. So two different ways to interpret this graph. So here is a second graph that we might have to interpret. And so first you have to be able to determine what's going on here. So on the x-axis, we have hours. And on the y-axis going up, we have miles. Now, this is not a one-to-one scale because every x-axis goes up by a half, and every y-axis, it takes several steps to get to that first full number there, 50. So we have 1, 2, 3, 4, 5. So if we count up, this is still 0. And so if we count up by 5, it takes 5 of them to get to 50. So you have to go 50 divided by 5. And then that will tell you that each of these tick marks is worth 10. So if we want to find out how many hours it takes to travel that far, we have to count up 10, 20, 30, 40. So we count up 40, and then we have to go over till we get to that point, which in this case would be 1. So what this is telling us then is that in 1 hour, we travel 40 miles. Or the opposite would be it takes, well, takes would be the wrong word in this case. We travel 40 miles in 1 hour. So, two different ways to interpret the graph. Basically, you have to be able to decide what numbers go where, and then be able to write a mathematical statement for these. Sometimes you get multiple proportional graphs. Now remember, proportional graphs are when you have a straight line. As you notice, A, B, and C are all straight lines, and they all have to pass through the origin, which all three of these are passing through the origin. So these are all proportional. Now, what we want to do then is be able to interpret or decide what graph is telling us what information. So, for example, if I had asked you which graph, because we have time in hours and miles ran, so how fast do each of these people run? So, which of these graphs, A, B, or C, shows who ran the fastest? Well, we have to look at each one of these. So to do that, we can go up to here, which is 7, and over to here, which is 2. So A, remember proportionality is Y over x. So we take the y value, 7 over 2, and that gives us 3.5. If we do b, we can go up, in this case, to a, because it crosses right there, a nice whole number. Here, that one crosses there. And then we come over here and find that that is 8 hours. So b's proportional graph is the 8 over 8, which is 1. So who is running faster, 3.5 or 1? So far, 3.5 is running faster. The last one then would be C, and we want to pick a nice, good spot to choose from. And so that's actually way out here at this point. And so we have to go up to C, we go up to 3, then we come way out here. That's 8, 9, 10. So that's going to be 3 over 10, and so that will be 0.3. So who is running the fastest? That would be A. And since we're doing this, it would be miles per hour. So this person runs 3 miles per hour, this person runs 1 mile per hour, and this person runs 0.3 miles per hour, which is pretty much a very slow walk. Even 1 mile per hour is a pretty slow walk. If you can walk 1 mile in 15 minutes, you're actually doing 4 miles an hour. So even this is not that fast. It's basically a nice semi-brisk walk. This is a very leisurely, strolling walk, probably by like a 70-year-old or someone who has a disability of some sort or a handicap. And this person is basically walking about 100 feet, taking a 5-minute break. So that's how you can interpret graph. Lastly, let's look at this graph here. So there's a couple things. One, is it proportional? Well, yes, it's a straight line. And 2, it does pass through the origin. And so first, how would we find the constant of proportionality? So remember, that is usually K or R over Y over X. So here's your Y value, which is hot dogs 8. Here's your X value, which is minutes. And so we can come up to this point right here. That means we're going to come up to 4 over 2. And so our constant of proportionality would be 2. Now, they also can ask different questions like, how many hot dogs are 8 in 1 minute? So that's what we want to know, is how many hot dogs can we eat in 1 minute? So in 1 minute, we can go straight up and see that we eat how many hot dogs? 2. It ends on a nice whole number, makes it really easy to do. And so basically that shows us that we are eating hot dogs in 1 minute. So that is the Y over X. And so hot dogs in 1 minute will give you 2 over 1, which means 2 hot dogs per minute. Now, the other one is a little different. How long does it take to eat 1 hot dog? So now we're talking about minutes per dog. So we're inverting this. So we don't know how long it takes to eat each dog. And so this time we actually have to go here. And so 1 hot dog can be done in 1 minute. And so that means it takes us 1 minute to eat 1 hot dog. That's all for this video. So next up is identifying proportional relationships. Check it out on Google Classroom, watch the video, and try the problems on Khan Academy.